Okay, let's look at the basketball problem. Okay, we're looking at the heights of basketball players on the y-axis compared to their age on the x-axis. Okay, so for example, here's a 14-year-old basketball player and 66 inches tall. That basketball player is 66 inches tall. Okay, so we just have this information. Okay, we have a line of best fit already. Okay, they gave that to us. Remember, a line of best fit is a line that goes through the middle of your points. You want to have about the same number of points above the line as below the line. Okay, this looks pretty good. Okay, what we want to do is find the equation of the line of best fit and use it to predict the height of a basketball player that is 19 years old. Okay, the trickiest part is the slope, because to find the equation of this line, we need the slope and the y-intercept. Okay, so the slope, okay, what I would do is find two corner points on the blue line. Okay, ignore the dots, ignore the red dots. Okay, this to me looks like a really good point on a corner that's also on the line. And let's see. I mean, that wouldn't be too bad right there. But I'm kind of thinking this point right there is better as far as being the corner. You know what? Maybe even this one. I'm just going to stick with that one. Okay, as long as you're trying to find 2 points that are pretty close to being on a corner, it's all good. Let's see. I'm going to go with 2, 4. Okay, so I'm going to go with that point right there. So to find the slope, I want to go from here to there. Okay, and I want to think rise over run. Now, this is the tricky part. If this was a regular axis and the numbering was the same on the x and y axis, the slope would be up 3 over 4. Okay, and that'd be the end of it. Okay, that'd be the slope. Okay, but if you look real carefully at the axes, the numbering, okay, look at the y-axis. Look at the heights. Here's 70. Here's 74. See, and there's 1, 2, 3 in between. It looks to me like they're counting by 1 inches. Okay, by ones. Okay, so this is 70. This is 71, 72, 73, 74. Okay, so the y-axis is counting by ones. Okay, but if you look at the ages, let's just pick two numbers that we see. Here's a 15 and a 16. See, it looks like every 2 spaces on the x-axis represent 1 year. Okay, or maybe you could think of it as every space on the x-axis is a half of a year. Either way you want to think about it. Okay, each individual space is a half year, or you could think that 2 spaces together make up a full year. Okay, so when you're doing slope, you need to think about that. So when you're going up 3 and over 4, okay, up 3 is really up 3 inches, because remember the y-axis is counting by ones, up 3. But when you go over 4, okay, you're not going over 4 years. You're going over 2 years. Okay, because each 2 spaces is equal to a full year. Okay, so think about it like this. Okay, you're going up 3 years. You're going over a half, another half, another half, another half. You're going over 2 years. Okay, so the slope would be up 3 over 2. Okay, not really what it looks like, but that's what it means. So 3 over 2. I guess I'll just go ahead and write that as a decimal, 1.5. You could keep it as 3 over 2 if you wanted. Okay, that's the trickiest part, guys. Really think about the numbering when you rise and run, and don't even think about the red points. Those red points don't matter. Okay, you're just looking at points, corner points on the blue line. Okay, the y-intercept, that's where the line of best fit crosses the y-axis. Okay, well, if this is 66, okay, and we're counting by ones, this would be 65, this would be 64. So the y-intercept is 64. Okay, the equation of the line, we're all set. Y equals slope x plus y-intercept. Okay, y equals the slope of 1.5 x plus, oops, I did two x's. Y equals slope x, 1.5x, plus the y-intercept of 64. Okay, there's my equation. Okay, now I'm going to use my equation to predict the height of a 19-year-old basketball player. Think about this just a minute. 19 years old, years is on the x-axis. So they're giving us x. Okay, they're giving us an x value. They're wanting us to figure out y because they're asking for height. Okay, so they're giving you x. They're asking for y. So all you need to do is take this equation, replace x with what they give you, 19, and find out what y is. Okay, so we're just going to do y equals 1.5. We're going to put 19 in for x. So we have y equals 1.5 times 19 plus 64. Okay, just multiply first. Multiply first. 1.5 times 19 is 28.5. If you add that to 64, I'm using a calculator, you can do the same. I'm getting about 92.5 inches. Okay, 92.5 inches. Okay, so a 19-year-old 19-year-old basketball player may be predicted to be 92.5 inches. Okay, we found the slope really carefully. We didn't just do rise over run. We realized it was going up 3 and over 2 years. Okay, we found the y-intercept by figuring out where it crosses the y-axis. We put the slope and the y-intercept into the equation, and then we predicted by putting 19 in for x. One quick thing here, guys. We predicted using the equation. We could also predict using the graph. We could go over to 19 years on the graph, go straight up until we hit the line of best fit. So it looks like a tad above 74. Okay, so we're getting about 74 inches. You're not always going to get the same amount. Sometimes the line of best fit is a little more accurate than the equation. It just depends. But that is something you could do. But on the Khan Academy lesson, you do want to use the equation. Okay, let me know if you have any questions.